Okay, today we went over standard review 3.3. This one says, what is the value of the missing number in the following equation? And it was 3 4/10 times some number equals 34 hundredths. Now, if we look at the two numbers and compare them, we can see that the place value, or the decimal point, it actually shifted one place value. So we know it's only a power of 10. It's either multiplied by 10 or 1/10. It's reciprocal. So if we look at it, if I multiplied 3 4/10 by 10, I would end up with 34. So it obviously has to be 1/10, which is C. On question 2, it said, when multiplying a number by 10 to the third power, how many place values and what direction is the decimal point going to move? Well, since we know it's 10 to the third power, we know that it's going to shift 3 place values. So we automatically can take out A and B. So we're left with C, D, and E. And we know it's 3 place values, so we know it has to be between C and D. Now we know when we multiply by a number, the decimal point is going to move to the right. So D would be 3 to the right. In this problem, we have 5 23 hundredths divided by 10 to the second. So on this one, we know since it's divided by 10 to the second, it's going to move 2 place values. So I can look, it's either going to be 523 or it's going to be 0.0523. So now if I was to multiply 5 2/3 by 10 to the second, it would be 523. So it's going to move 2 positions to the left, 1, 2, and that gives us D, which is 0.0523. And the last question said David multiplies and divides the original numbers by powers of 10 to make new numbers. Which original numbers were multiplied by 10 to the second power? So we're looking for a number that when it multiplied by 10 to the second, it's going to move the decimal point 2 places to the right. So if I look at this, if I multiply 523 by 10 to the second, which is equal to 100, it would end up 2 places. It would be 52,300. So 523 is not the answer. On the second one, if I multiplied it by 100, it would move 2 place values, and it would be 5/10. 100, if I multiplied it by 100, it would give me 10,000. 600, if I multiplied it by 100, would give me 60,000. So this 600 is a good answer. 4 56 hundredths times 100 would give me 456. It's not good. And 37 9/10 times 100 would give me 3,790. So the correct answer was 637 9/10, which would have been B. Now our objective for today's lesson is students will round a given decimal to any place using place value understanding and the vertical number line. And what you should be thinking about at this point is, how can I use what I know about place value and a number line to round decimals? Now here we have a standard place value grid, and we're going to decompose 156. Now 156 as is written is in standard form. When we decompose it into unit form, we're actually going to place those values, those digits, into its proper place value. So I have 1 hundredths, 5 tens, and 6 ones. Now if I want to rename this using the greatest number of tens, I know there are 15 tens in 156, and that leaves me 6 ones. So renaming it in tens would be 15 tens and 6 ones. So now if I wanted to rename it in ones, I would read the number 156 ones. So 156 ones. Now we've decomposed it. Now we're going to use it to make a vertical number line. Now here it says I'm going to round to the nearest 10. So I'm looking at my tens, and I'm looking at the unit form in tens, and it says 15. So the bottom of my number line is going to be the number of tens I have in my number, which is 15. Now the question is, this number, when it's rounded, is it going to be cut to the nearest tens? Is it going to be 15 tens or the next highest one, which is 16 tens? Now the question you have to ask yourself is, what is in the middle? Well, right in between 15 tens and 16 tens, we know we have 15 tens and 5 ones. Now that we have that, I'm going to compare 15, 10, 6 ones. If I were to take that and try to slide it in, would it go below or above our center point? Well, 15, 10, 6 ones. Here I got 15, 10, 5 ones. So we know that it would be approximately right here. So since it's above the middle, we know it would be rounded to 16 tenths. Now taking the same problem, if I round it to the nearest hundredths, look at how we broke down our hundreds chart. We have 1 hundredths, which would be the bottom of my number line. Now that means the top one is 200, because the question is, are we going to round to 100 or 200? Once again, what is in the middle? Well, right between 100 and 200 would be 100 5/10s, which would be 150. Now, when we compare our 100 5/10s, we can see this one here is 100 5/10s with 0 ones. This is 100 5/10s with 6 ones. So it would go above the middle point, telling us that we would round to 200. Now let's look how we decompose the next number. This is 4 and 381 thousandths. So when I take it from standard form and plug it into our place value chart, you can see we have 4 ones, 3 tenths, 8 hundredths, and 1 1,000ths. Now if I rename it in tenths, I read 43 tenths, 8 hundredths, 1,000ths. If I wanted to rename in hundredths, I would read 438 hundredths, 1,000ths. And if I wanted to rename the whole number in thousandths, I would read 4,381 thousandths. Now, once again, we're going to round, and we're rounding to the nearest 10. So if I look at my tens over here, I have no tens. So that's what's going to be in my bottom of my vertical number line. So the question is, it 0 tens or 1 10 away from that, which is 1 10. Now I'm looking in the middle. If I have 0 tens and 1 10, what's in the middle is 0 tens, 5 ones. Now I'm going to compare. I have 4 ones, 0 tens, 4 ones. I have 0 tens, 5 ones. It's below my midpoint, so we would round to 0 tens. Now, coming to the next slide, we have round to the nearest ones. So I'm coming to the ones, and it says I have 4 ones. So that's what's going in my center, excuse me, in my bottom. And I know my top is always going to be 1 more than that. And then I ask myself, what is in the middle? Well, I have 4 ones, 5 tenths in the middle. Now I'm going to compare my 4 ones, 3 tenths, and my 4 ones, 3 tenths would be below the line, so I would round to 4 ones. Now round to the nearest tenths. So I'm coming to my tenths position, and I can see I have 43 tenths. So that goes to my bottom of my number line. 1 more tenth, because the question is, does it round to 43 tenths or 44 tenths? What is in the middle? Well, I can see 43 and 5 hundredths. 43 tenths, 5 hundredths. Now I'm going to compare 43 and 8 tenths to 43 tenths, 43 tenths, 8 hundredths to 43 tenths, 5 hundredths. And I know it would be above, so that means we would round to 44 tenths. Now, when we round to the nearest hundredths, we're going to rename it in unit form to hundredths. So we're reading 438 hundredths. And that goes in the bottom of our number line. We know 1 more because the question is it 438 or 439 hundredths? What's in the middle? It's always 5 of the next place value. So it would be 43 hundredths, 5 thousandths. Now we're going to compare our 438 hundredths, 1 thousandths to 5 thousandths, and we know that would be below, approximately right here on our number line. So we know we would round down. Okay, I hope this helps you with your understanding of how the place value system works with rounding. Our ultimate goal would be to be able to look at a digital number, a standard number, and be able to round it. But this here is a strategy to help you in case you are not doing very well on the other strategy. Remember, a good mathematician knows what strategy they want to use. An effective strategy is one that you get the answer right every time. An efficient strategy is one that you get it right every time, but it's reduced steps. Maybe you don't have to draw it out every time. Okay? All right, well, I think that's it for this session. Have a good day. Bye-bye.